So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another physics lecture. So we were discussing section 2.2, thermal properties and temperature. We have discussed the differences between boiling and evaporation in our last video. Now moving ahead, the next topic we have in this section is latent heat of fusion. Energy that is transferred to a solid during melting or given out by a liquid during solidification or icing is called latent heat of fusion. The state change occurs without change in temperature, as all the energy is used up in increasing the distance between molecules or atoms, so that the solid can convert into a liquid, or vice versa. This can be calculated by delta E equals to M, means mass, into latent heat of fusion. Sometimes you will be given the value of latent heat of fusion and you will be required to calculate energy change, whereas sometimes you will be provided with energy change and mass and you will need to provide the latent heat of fusion. We have another thing that is known as the latent heat of vaporization. It is the specific latent heat of a substance. It is basically defined as the amount of heat required to change a unit mass of a substance from liquid state into gaseous state. Means the energy that is required to liberate the atoms of a liquid and convert them into steam or a gas, a vapor form. The formula is same as the latent heat of fusion. Delta E equals to mass multiplied by LV, latent heat of vaporization. Latent heat in terms of molecular behavior. Latent heat energy is absorbed or given out while a substance undergoes state change. The average kinetic energy of the molecules does not change, so that the temperature remains constant. Why? Because the energy being provided is being used to break, either form new bonds or break the existing intermolecular forces. During melting, heat absorbed by the solid is used to break their intermolecular bonds, whereas during vaporization this heat is absorbed by the liquid to break the intermolecular bonds completely between the molecules of liquid substances. Example question: define the specific heat capacity of a substance. The thermal energy required to raise temperature of a mass of 1 kg by 1 degree centigrade. Figure 4.1 shows a cylinder of aluminum heated by electrical heater. Here you can see this is a heater, there is a thermometer. This is basically the setup used for experiment to find out latent specific heat capacity of an object, which we have discussed in our previous video. The mass of cylinder is 800 grams. This heater delivers 8700 joules of thermal energy and it raises the temperature by 12 degrees. Calculate a value for the specific heat capacity. We know the formula, Q is equals to mc delta theta. So we rearrange it as we have to find C over here. So C becomes Q divided by m delta theta. 8700 divided by 800 into 12 gives us 0.91 joules per gram centimeter cube. Why grams? Because the mass was given in grams. If you want it in kilograms, you'll have to convert this into kilograms and this would become 0.8 kg. Calculate the thermal capacity or heat capacity of the aluminum cylinder. Heat capacity is not concerned with the mass of an object. So if you just have to find heat capacity, the thermal heat provided, lost or gained by an object, then you simply use the formula Q equals to C delta T or delta theta. Let's rearrange it as we have already known the value of a specific heat capacity, C. So C becomes Q. Sorry, we have to calculate the thermal capacity. Over here C represents the thermal capacity, whereas delta T represents the change in temperature. So Q is the energy supplied. Energy supplied is given here, 8700 joules. So we'll rearrange it to calculate C, that is heat capacity or thermal capacity. Now C would become Q divided by delta theta or delta T. Q is 8700 joules divided by delta T, that is 12, gives us 725 joules per degree centigrade. Now before we quit, let's just have a few more questions from the past papers on this topic. So a sealed container of gas is heated and the pressure inside increases. What happens to the molecules of the gas to cause this increase in pressure? The kinetic energy decreases, they become heavier, they expand, they hit the container more frequently. Now the reason for that would be D would be the correct answer, as when the pressure increases, volume decreases. Because of that, molecules hit the container walls faster. Equal masses of copper and water are heated to the same temperature. As they cool down, the copper and the water loses thermal energy at the same time. The temperature of the copper falls faster. Why is this? Copper has a greater specific heat capacity. That is not possible. If it has greater heat capacity, it would cool down slower. Copper has a larger specific latent heat. Copper has a smaller specific heat capacity. Copper has a smaller specific latent heat. So the correct answer for this is C. Copper has a smaller specific heat capacity. Moving on, we have another question. A 100-gram piece of solid lead at room temperature is heated. After 22 seconds, it has all become liquid. Means it has been completely melted. The graph shows how this temperature varies with time. So we start at around 20. So we start off at 20 degrees and it is heated till 320 degrees, and at that temperature it becomes liquid. The power of the heater is 320 watts. Which expression gives the specific latent heat in joules per kg of the lead? Specific latent heat of over here we would be calculating the specific latent heat of fusion. Now the formula for that is supposed to be change in energy equals to mass into latent heat of fusion. Now latent heat is the value we have to calculate, so we rearrange it and it becomes change in energy divided by our mass. Now for change in energy we are given the power in watts and we are given the time that at 22 seconds it has become all solid. So the power is 320 multiply by 22 would give us the total energy provided. As discussed, we only have one expression that uses this. But over here we need to keep in mind is that 22 seconds is the total time it takes for a solid to be heated to convert it into liquid, whereas latent heat of fusion only occurs in this part from here till here when a solid is being melted. So that means we have to start our time at 15-second mark. So that actually means that this portion actually only takes about 7 seconds. So we multiply 320 with 7 and then we divide it by the change in temperature. Now what is the change in temperature? Sorry, not the change in temperature, the mass. As per the formula we have this change in energy equals to mass into latent heat of this we have to find. So we divide the change in energy divide by mass. So our mass is supposed to be 100 grams. When we convert it into kg, because we need the answer in kg, so it becomes 0.1 kg. So C would be our right equation, 7 into 320 seconds into power divided by the mass in kg. So C would be our correct answer. Now we have another question. It is a temperature time graph for a sample of wax that is heated so that it melts. Mass of wax is 200 grams. Thermal energy supplied to wax at a constant rate of 12,000 joules per minute. What is the specific latent heat of fusion of wax? So again we only consider this part. This is 3-minute mark and it goes on till 7-minute mark, so that means energy is being provided for 4 minutes and energy is supposed to be 12,000 joules per minute. So 12 fours of 48,000 joules is being provided per minute. That is divided by 200, because over here we need the answer in grams, not kilograms, so we simply divide by mass, that is 200. So 48,000 divided by 200 would give us, that would give 48,000 divided by 200 would give us 240 grams, sorry, 240 joules per gram, and that would be our answer. So that is it from this topic. I hope you have understood everything. If you still have any problems, please do feel free to contact me. Leave your comments below and I'll be sure to answer your queries. And I'll see you guys in the next video. Till then, take care. Allah Hafiz.